Today we're going to be talking about parallel and perpendicular lines. So if you look here, these are parallel lines and these are perpendicular lines. So let's talk about parallel lines first. The definition for parallel lines are lines that never intersect. So they'll never cross. They never meet each other. So that never intersect. Or you can think of that, they never intersect or they never touch. So algebraically, meaning with math, how do we know if two lines are parallel? So we know because they have the same slope. So they have the same slope. And if they have the same slope, they'll never touch. So let's look at an example. So think about y equals mx plus b. Which one's the slope? If I said, don't write this down, but just look. If I said y equals mx plus b, which one would you tell me is your slope? Your y, your m, your x, or your b? It's going to be your m. So remember, this is your slope, isn't it? So if that's your slope, and we're going to look at two equations, let me give you an example. So if we had y equals, so you can write these down, y equals 2x plus 1, and y equals 2x minus 7. What do you notice is the same? The m, or the slope, are the same here, right? They're both 2. So these two lines are parallel. These two lines are parallel. These two lines are parallel because they have the same slope. But if we are talking about perpendicular lines, these are lines that intersect at 90-degree angles. Lines that intersect. Another word for intersect is touch or meet, right? So they intersect or they touch at 90-degree angles. So algebraically, remember algebraically, we're talking about like algebra here. So with math, right? With math, we can think of algebraically as with math, with some kind of equation, how do we know if two lines are perpendicular? Well, instead of having the same slope, they have opposite, or they have negative or opposite reciprocal slopes. Now, what the heck does that mean? Well, here they have opposite or negative reciprocal slopes. We're going to talk about down here. It says, what are negative reciprocal slopes? Negative or opposite reciprocal slopes. We're going to talk about that down here. But let's look at an example really quick. So for perpendicular lines, if I gave you y equals 2x plus 1, so notice it's the same example that I gave up here, right? Y equals 2x plus 1. A perpendicular line would be something that looks like this. Y equals. So it says they have negative, perpendicular lines have negative reciprocal slopes. I'm going to do a negative. See how I just put a negative? And reciprocal is the flip. So 1/2. What's 2? If I flip that over, remember you could put 2 over 1. It's 1/2. So I'm going to put a negative reciprocal, negative 1/2, x, I don't know, and it could be anything, plus 5, minus 100, plus 0. As long as these two are negative reciprocal. It doesn't matter what the two other pieces of the equation are. Okay, so if you want to write, just to remind yourself, these lines are perpendicular. And I'm going to show you what perpendicular, we can write it like this. Do you see that? That just means perpendicular. Okay, so I'm going to write it like that. Those lines are perpendicular. So let's look at what are negative reciprocals. We talked about it up here. So two perpendicular lines to each other have to have negative reciprocal slopes. What are negative reciprocals? Well, negative reciprocals are a fraction. I'm going to put this just down a little bit. Okay, a fraction flipped So we flip the fraction and the signs are switched. So if it's a positive, we turn it to a negative. If a negative, then we're going to make it a positive. That's what it means for the signs to be switched. So when I say they have to be perpendicular, we're talking about negative reciprocals. Negative reciprocals, a fraction flipped and the signs are switched. So let's look at some examples. So the fraction is flipped. Let's flip the fraction. And the sign is flipped. Sorry, the sign is switched. So a fraction flipped, when we're looking at the negative reciprocal of 2, we have to say, okay, well, 2 is technically, isn't that over 1? We can put a number over 1. So what would that be flipped? 1/2, a fraction flipped, and the signs are switched. So instead of a positive 2, it's a negative 1/2. Now see 7/8, we're going to do a fraction flipped, so 8 over 7. And what is the opposite of a negative this time? Well, we're just going to keep it positive. Okay, a fraction flipped, so remember 1 is over 1, right? So we're going to write 1 over 1 again. And then negative. Signs are switched. 0. Okay, for 0, let's think about this. 0 over 1, right? 0 over 1. What would that be flipped? Wouldn't it be 1 over 0? And then we could say the signs are switched, so it's a negative 1 over 0, right? What's any number? When there's a 0 on the bottom, what does that make that whole entire thing? Undefined. So when one slope is 0, the opposite reciprocal is undefined. So that is important. That was a tricky one, number 5. Make sure you understand that. When you have a slope of 0, the opposite reciprocal is a flip of the fraction, or the negative reciprocal is 1 over 0, and then you take the opposite. So because it was positive 0, it's a negative 1 over 0. But any number, when a 0 is on the bottom, is undefined. When the 0 is on the top, it's 0. Okay? So let's see if AB and CD, so here's this line, this segment AB, and this segment CD. We're going to see if they're parallel, perpendicular, or neither. So here's what we do. We're going to start with AB. Okay, we're going to find the slope of each one, because isn't that what we've been doing? We know if lines are parallel, if they have the same slope. So look up here, if they have the same slope. And we know that they're perpendicular if they have negative reciprocal slopes. So we're talking about slope every time, aren't we? So let's find the slope for AB and see what we're talking about. So the slope, remember the slope is m. So the slope is y2 minus y1 over x2 minus x1. So that's, we're going to make this piece a positive, right? Negative minus a negative is a positive. So 6 minus 3 is 3 over 4. Okay, let's look at CD now. Okay, let's find what the slope is. So we have y2 minus y1, 3 minus 0, over x2 minus x1, 3 minus negative 1. All right, we have that minus a negative again, so that's a positive. 3 minus 0 is 3, 3 plus 1 is 4. So are those two slopes, are A, B, and CD, are they parallel, perpendicular, or neither? Well, since they have the same slope, 3/4 and 3/4, they're parallel. Remember up here it said lines that have the same slope, right here, same slope, are going to be parallel lines. All right, let's try number 2. Okay, so let's do it again. We have AB, so let's start with AB. Be very clear of what you're looking for so you don't, make sure your work is neat. So we're doing y2 minus y1, so 4 minus 2, over x2 minus x1, 5 minus 0. So 4 minus 2 is 2, 5 minus 0 is 5. Okay, now let's find the slope for CD. y2 is 3 minus y1 is 8. x2 minus x1 is 3 minus 1. So we're just doing the slope formula. 3 minus 8 is negative 5. 3 minus 1 is 2. Well, is 2/5. Remember, perpendicular slopes have negative reciprocal slopes. And what are negative reciprocals? It's a fraction flipped and the signs are switched. Is the fraction flipped here? 2/5 and 5/2? Yes. Is the sign switched? Negative and a positive? Yes. So this is perpendicular. Okay. Let's do 3 and 4. So AB, we're finding the slope. So M equals y2 minus y1, so 6 minus 8, over x2 minus x1, so 2 minus negative 1. So when we have minus and negative, we make that a positive. 6 minus 8 is negative 2. 2 plus 1 is 3. Negative 2/3. Okay, let's find CD. So M equals y2 minus y1, so 3 minus 2, over x2, 3 minus negative 1. 3 minus negative 1. So we make this a positive when we have two negatives next to each other. 3 minus 2 is 1. 3 plus 1 is 4. Okay, are those the same? No. Are these two slopes opposite reciprocal? No. So this time it's neither. So it's neither parallel nor perpendicular. Okay, I'm going to do 4, and then I want you to do 5 through 8. So let's do 4 together. So y2, finding the slope again to see if they're parallel, perpendicular, or neither. So 4 minus 3 over negative 1 minus 2. 4 minus 3 is 1, negative 1 minus 2 is negative 3. CD. 6 minus 3, y2 minus y1 over x2 minus negative 5 equals, so remember this makes a positive. 6 minus 3 is 3. Negative 4 plus 5 is 1. Okay, so 1/3 and 3/1, and we have a negative 1/3 and a positive 3/1. So those are perpendicular. They're opposite reciprocal slopes. Get the picture? So try, hopefully you're starting to understand this. If not, raise your hand and I'll come around and help you. I'm more than happy to help. So try 5 through 5, 6, 7, and 8. See if you understand those. I would be careful with number 5. I'm going to put a little star by that. But I want you to try 5 through 8. Okay? And then what if, so that's if we're given 2 points. If I said find or tell me if those are parallel, perpendicular, or neither. And I give you technically 4 points, right? And I say, okay, here's AB and here's CD. Tell me if those two are perpendicular, parallel, or neither. What if I gave you 2 lines? So for number 9, if I said, tell me if these are parallel, perpendicular, or neither. What does a parallel mean? It means that the slopes are the same, right? They have the same slope. What about perpendicular? They have negative reciprocal slopes. So let's look at our lines and see if they're parallel, perpendicular, or neither. When we're looking at parallel and perpendicular, we're looking at slopes, right? So tell me what is the slope for number 9? So what's this slope? Remember, M is the slope. What is M? Y equals mx plus b, mx. So my slope is 7. Don't put 7x. Just write the number in front of the x. So your slope is always just the number. So slope is 7. What about your slope here? Your slope is 7 again, right? So both of them are 7. So those 2 lines are parallel to one another. What about number 10? So our slope here is 4/5. Remember the number in front of the x. And our slope here, number in front of the x, is negative 5/4. 4/5 and negative 5/4. Those are opposite reciprocal of each other, right? Negative reciprocals. So that's perpendicular. Okay, what about the next one? Number 11. So negative 1/3 and 1/3. Are they flipped? No. So it's not 1/3 and 3/1. And even though one's a negative and one's a positive, that means they're not parallel either. So in this case, they're neither parallel nor perpendicular, because look, negative 1/3, and this is 1/3. So they're neither parallel or perpendicular. Okay, let's try number 12. So number 12, we have to get y alone, don't we? Because we need to find the slope. Notice for 9, 10, and 11, they were all in y equals mx plus b, right? Y equals mx plus b, y equals mx plus b, okay, y equals mx plus b. This said y equals mx, but there's just no b, and that's fine. That's still in that form. So we need to get y alone for number 12. That's our first step. We need to get these both into y equals mx plus b. So let's subtract x. Remember, we always get rid of the x first when we need to get it in that form. X minus x is 0. We have 6y equals, put the x term first, negative x plus 30. And then we divide each side by 6. Now, remember, we divide each number by 6. 6 is canceled. We have y equals. Remember, when you have negative x over 6, I want you to imagine there's a 1, because there is a 1 right there in front of it. So it's negative 1/6, and then put the x on the outside. That's how we write it. 30 over 6 is 5, so plus 5. Okay, that's one of my lines. What's my slope here? My slope is negative 1/6. So now we're going to look at the next one. So here, look, the y is already by itself on one side. I just need to divide each piece by 3 to get the y alone. So y equals 18 divided by 3 is 6, so 6x. 6 divided by 3 is negative 2. And what's my slope here? 6. So are these two lines parallel, perpendicular, or neither? So here's negative 1/6 and 6. Remember, 6 can be written 6/1, right? So these two are perpendicular. Okay. I will do number 13, and then I want you guys to try 14 and... Actually, you guys try 13, 14, and 15. I'm going to do 16. So look at this. This says y equals 6 and x equals negative 1. Okay, I want you to picture this. So I'm going to draw a little graph. When I have any y equals, it doesn't matter what y equals it is. When I have something that's y equals... Doesn't it look like that? That's y equals 6, right? What's the slope here? Well, my slope is 0. Remember, if I have someone walking across this, it's no slope, right? It's just zero, not no slope, it's 0 slope. Now, if I have x equals negative 1, negative 1 is here for x, right? This is my line. And remember, if I have someone up here and they jump off, they're undefined. So my slope here is undefined. Do you remember when you have a 0 slope and you have an undefined slope, what it is? So let's look over here. Remember when you had a 0 slope? Remember it was just 0? And then you have undefined. Remember that those are negative reciprocals of each other? And negative reciprocals mean that they're perpendicular, right? They have negative reciprocal slopes. So that means these two, m equals 0 and m equals undefined, when you have both of those, this is perpendicular. Both of these lines are perpendicular to each other. All right, so why don't you try 13 through 15 and 5 through